So today we're going to talk about amplitude and period of both sine and cosine functions. We'll talk about what amplitude and period does to the graphs of functions. We'll talk about what amplitude and period do to stretch and smush all the different graphs and functions. We're going to begin today talking about the graphs of just the basic. The graph of sine, y equals sine of x, y equals cosine of x, are known as the parents. Those are the parent functions. Those are the ones that we look to for guidance. And what do we do in telling us what to do when we do things like insert a number in various places into those equations? What happens to the graph? All right, number one, this picture is a graph of y equals sine of x. Important features of that, I want you to pay attention to the high and the low. These tick marks are each one, so you can see it has a high of +1, a low of -1. This graph has a period that starts here, and as you look and see, where does it hit that again and start to rise again? Right here. I went and set these tick marks at half a pi, so there's half a pi and a pi, 1.5 pi's, and 2 pi's down here. So the period of this cycle, of this graph, is 2 pi. It finishes everything, a full cycle, in the span of 0 to 2 pi. It also has some x-intercepts. Those help us in graphing. Its x-intercepts are here at 0, here at pi, and again at 2 pi. And then it continues following those same intervals. Let's compare that to what happens when we look over here. Here I started this with the exact same y equals sine x, the exact same scale, so that these are all, these tick marks are all half a pi. So there's 1 pi, there's 2 pi. These tick marks here, you can see the original parent function has a height of 1, low of -1. The second one that I put in this picture is y equals 3 times the sine of x. Well, what happened when I did y equals 3 times the sine of x? Well, my high value is no longer 1. My high value is now up to 1, 2, 3. My low value, how low does this graph go? Goes down to -3. Those changed our graph dramatically. The period is still, if I start here and I continue up and down, you can see that it continues one cycle. The period is still at 2 pi. What happens to the intercepts? The x-intercepts are still exactly the same as they were for y equals sine of x. We cross the y-axis or the x-axis at 0. We cross the x-axis at pi. We cross at 2 pi, then again at 3 pi, 4 pi, 5 pi, and so on. So that number out in front here, the only thing that really changed were my high and my low points. That number is our amplitude. Now let's take a look at this one. What happened in this graph here? Again, I've drawn in right here, that thin one is still my parent, y equals sine of x. My scale is still the same, so I'm at a height of 1, a low of -1. And if you can see way in the back there, where is my one cycle? One cycle finishes right here at 2 pi. Pi is over here. You can kind of see that one in the background, but what I really want to pay attention to is that thick black function. That thick black function is y equals the sine of 3x. So y equals the sine of 3x. What's different? Well, let's see. My high point is still 1. my low point is still -1, just as it was over with my parent function on this side. My period has changed dramatically, however, because what you saw here was that my original parent had a cycle of 2 pi, finished one full cycle in 2 pi. What does this one do? This one begins at the same place. There's one cycle. Then it continues. There's 2 cycles. Then it continues. It completed 3 cycles in the time it took our parent to finish one cycle. So how far did it take to get to one cycle? Well, if it took 2 pi for the original parent, we're dividing that by 3. 2 pi over 3 is one cycle. That changes our x-intercepts. Our x-intercepts changed quite a bit. We still cross the x-axis at 0. We then cross again at, it looks like, every pi over, let's see, there's pi right here. Looks like we're crossing at about pi over 3. Then again at 2 pi over 3. Then we cross again at pi. And then 4 pi over 3 and 5 pi over 3 and 6 pi over 3. So we're crossing the x-axis a lot more often. Let's see what's going on here. Let's see if we can put it together, make some rules about this. This number out in front, we'll deal with that first. If I take my parent function and I put a 3 out in front of it, that number is known as the amplitude. What is an amplitude? An amplitude tells us how high and how low a graph will go. Putting a number out in front of sine x, cosine x functions takes our graphs and causes them to stretch or compress vertically, that is up and down. It changes the range. The range, recall, are the y values of our function. It changes those highs and those lows. The period doesn't change. However, those high and low values are going to change a lot. The intercepts don't change at all. If a is a number smaller than 1, we have a flatter graph. If a is bigger than 1, we have a taller graph. So it's possible for me to put, for example, 1/2 cosine x, then my graph is going to only go up to a height of a half and down to a low of -1/2. This number that I put in front here, this time I put the 3 out in front of the x instead of in front of the word sine or the word cosine. That number causes our graph to compress or stretch horizontally, that is along the x-axis. It has no effect on the domain or range. So it only changes along the x-axis. It changes the period. How do you find the period? If you're dealing with radians, we do 2 pi divided by whatever that number might be. If we're playing in degrees, then we're going to do 360 divided by whatever that number seems to be. If I take that number b, if that number b happens to be positive, then we get a narrower compressed graph. If that number happens to be a fraction, then we get a wider graph. For example, if that was 1/3 x, sine of 1/3 x, then it would only finish 1/3 of a cycle in the time it took the original to finish one cycle. Ha! This is my favorite. I wish I could find this t-shirt somewhere in a store. If you ever find it, get it for me and I'll pay you back. Love it. So let's see if we can put it all together, do one quick problem dealing with everything. Here we've got an equation, y equals 3 times the sine of 2x. We should be able to identify all kinds of information with this. Let's start, before I try to graph this, let's identify things. The amplitude. Well, the amplitude is this number out in front. That amplitude is a 3. The period is related to that 2x, but remember 2 pi over 2, not 2x, 2 pi over 2. I can certainly simplify that and make that pi. So that when I'm taking a look at my graph, I know I'm going to have to go up to a height of 3. I know I'm going to have to go down to a low of -3. I know that I'm going to finish one cycle at pi. If I just label 2 pi in there and then label the halvesies, here's half a pi, here's 1.5 pi, and I get things started to label based on what that period is going to be. I know my high point is going to be at 3, my low point will be at -3. Where will this thing cross the x-axis? Well, let's take a look at graphing this. It's the sine function, so it's got to start here at 0. It's going to finish one full cycle here, so it finishes half a cycle at half a pi. That means that halfway between 0 and half a pi, it hits its high of 3. It's going to hit its low, so it starts at 0, goes up to a height of 3, hits pi over 2. Halfway between pi over 2 and pi, it will hit its low, and then it's going to rise back up at pi. There's one full cycle. Where did it hit the x-axis? At 0, at half a pi, and again at pi, and it'll continue touching the x-axis every half a pi. Again, if I want to continue going, I go halfway between 1 pi and 1.5 pi. That's where it hits its high. Then it hits the x-axis again at 1.5 pi. Halfway between 1.5 and 2, it hits a low, and then it comes back to 2 pi. Notice what this thing did was it completed 2 cycles in the time it would take a parent to complete one cycle, which is 2 pi. This is the kind of information you should be able to do with any of your homework problems. Up here, you're just being asked to match. This is a matching game. We've got a bunch of equations down here. Figure out what their graphs are. Keep in mind that these are done in radians. So when it says 1, 2, 3, 4, and 5, that's 1 radian. 2 radians. Remember how big a radian is? Little less than 60 degrees. Then you're also going to be asked to write some equations and based off of information or off of a graph. Have a great day. Let me know if you have questions. Bye-bye.